everyone, welcome to Let's Unbound. I'm back with another video on 5 marker questions from Math Kangaroo 2024 exam for level 5 and 6. So without any further delay, let's get started. We did question 21 to 25 in the previous video, so let's get started with question 26, which is here on the screen. Mary wants to write the numbers 1 to 8 on the vertices of a cube. She wants the sum of the numbers on the vertices of each face to be the same. She has already written the numbers 6, 7, and 8 as shown. What number should she write on the vertex marked with the question mark? So you can have a look. There's a question mark here. We need to find this. And they have already marked 3 numbers here, 7, 6, and 8. So there are a few things we need to understand from the question. One is the numbers are going to be from 1 to 8 only. Second, all the numbers are used from 1 to 8, right? So if all the numbers are used from 1 to 8, one thing is very, very clear, that the sum of all the digits from 1 to 8 is going to be 36 on cube, right? So what about another thing? We need to find this digit which is hidden behind the question mark. Let me see if all the numbers, when added is 36. So what if I take only the digits on this face, which is at the bottom? It should be half of 36, right? Or if I take another face, let's say this, again, I get 4 digits as vertices. So that should also be the same, right? Okay. So one thing is clear, that the half of 36 is going to be 18. So let me give some alphabet here. Let's say A and B. So I am focusing on two faces. One is the bottom face, you can see here, and another is the side face, you can see here, right? Because I can see there is something common between them, that is these two, right? Okay, so let's get started. For the bottom face, where we can see 6, 8, the question mark digit, and of course, I've labeled A, right? So 6 plus 8 is already 14. And we have to make the sum of the face should be what? Should be 18. Just now we saw that half of 36 is 18. So if I want to add these four, it should be 18. Okay, so what will be 18 minus 14? It will be 4. So that means this 4 should be the sum of these two digits. Yes or no? Yes. So what are the combinations in which we can get 4 from the digits other than 6, 7, 8? So 6, 7, 8 are already used, right? So let me just strike this off so that there is no confusion. Now you can think of the remaining digits. So we know 4 can be formed by 2 plus 2, 1 plus 3, and 3 plus 1, right? And let's just be specific with the first digits as the digits which can be put on the question mark vertex, and the other one which I labeled as A. Is there any other possibilities for 4? No. Now, just look at the first possibility, which is 2 plus 2. We don't have 2 times. There is only 1 2. So that means first possibility is not possible. The second one is 1 and 3, and the third is 3 and 1, which is possible. Okay. But we cannot just come to the conclusion, because we have another phase where we see there is a common vertex A. So let's see what matches with both the faces so that we can decide on that what should be best for A, B, and question mark. Ultimately, we have to find this, right? That's our target. Okay, so for the other face now, which is this one, already the numbers are 7 and 8. So what is the sum of 7 and 8? That is 15. Okay, so that means the other two means A plus B. All right. So let me write it. Or I can say B plus A. That should be what? It should be 18 minus 15, right? Because don't forget this. So 18 minus 15 is 3. Okay. Now, let's see. What are the combinations possible for B and A? So let me write here B and let me write here A. How can we form 3? Either we can say 1 plus 2 or we can say 2 plus 1. We don't have a 0, otherwise we could have taken 3 plus 0 as well, right? So just be very careful while choosing the digits from the list which we have. The list is only this much, out of which 6, 7, 8, they're already there on the cube. Okay, now let's just have a combination. 1 and 2 is also possible. 2 and 1 is also possible. But we have to pick that one which should coincide with the above combinations also, because after all, the A can pick only one digit, not two different digits, right? So which one matches the best? What if I take this, the one I have highlighted? In both the cases, we are getting the right value for A, that is 1. And also, we are getting the values for the question mark digit, that is 3. And for B, that is 2. Okay, we don't have to worry much about the other digits. Ultimately, we need to find the question mark digit, but it's important to choose the correct options because it should not violate the property, right? It should still maintain that 3 plus 1 gives you 4, and that's, perfectly well makes you 18. Similarly, here, if I pick 2 plus 1, you will see that that will make 3, and ultimately the sum of all four should give you 18. Okay, so that means we have selected these two, and from both these two options, we got to know that A is 1. So let me put A as 1, question mark as 3, and B as 2. To cross verify your answer, you can just add them up and see whether you get 18 or not. Similarly here, right? So what is my question mark digit? Very clearly option C, right? And you can see option C is correct. So that's how we are going to do our question. Next question, which is question 27. Let me read it for you. A grandmother has some candy. She decides to divide it up among her grandchildren so that each has a bag containing the same number of pieces of candy. She puts the largest possible number of pieces of candy in each bag. When she is done, there are 20 pieces of candy in each bag and 12 pieces of candy are left over. What is the smallest possible number of pieces of candy she could have? Some important things to highlight here. So, there are 20 pieces of candy in each bag and 12 pieces of candy are left over. Also, if you notice here, she has put largest possible number of pieces of candy in each bag. Largest possible. Okay. And now they're asking us what is the smallest possible number of pieces that she could have. Right. So from all this information, we understand one thing. Each bag contains 20 pieces of candies. Right. And we are not aware that how many bags of candies are there. That means how many grandchildren she has. We don't know. But one thing we know that she has divided equally among all of them. You can see a bag containing the same number of pieces of candy. So same number means it will be equal for all the bags. And she has given largest possible number of pieces. That means if 12 pieces are left, definitely it means the number of grandchildren might be more than 12. That's why she couldn't distribute 12 equally among them. Because if the grandchildren would have been 12, she can again give one more candy to each one of them to finish off those remaining 12 candies as well. That means we get one information. So 12 candies left, which means grandchildren are definitely greater than 12. So we are picking 13. Okay. So then it means what? It means 20 candies in each bag. And if there are 13 grandchildren, so 20 times 13 will give me the total amount of candies. Also, we are going to add in that equation 12 because 12 pieces are left. And then let's see total comes out of which of the following options. So here we see 20 times 13 plus 12, which gives me 272. Okay, so it's very simple. 272 is option C, and how easily we land up to our correct solution. All we need to emphasize is on to read the questions properly and what they are stating, and each and every word matters, right? So let's just move to our next question. Question number 28. Dan plans to cut a rope into 12 pieces, 12 equal pieces, and marks the points where he needs to cut. Muhammad plans to cut the same rope into 16 equal pieces and marks the points where he needs to cut. Then Maya cuts the rope at all the marked points. How many pieces does Maya get? Okay, so few important information here. What all we have? We have 12 equal pieces. So Dan plans to cut in 12 equal pieces. So these many pieces he wants, right? So 12 pieces if he wants, it means how many cuts he will make? 11 cuts on the rope, right? Because if 11 cuts are there, how many pieces you are going to get? One extra, that will be 12. Okay. Similarly, Mohammed plans to cut the same rope into 12 equal pieces. So for 12 equal pieces, how many cuts are required? For 16 equal pieces, we need 15. Like for 12 pieces, we required 11. Okay. Now Maya cuts the rope at all the marked points. So she has already cut the rope into those many pieces based on the marked points, right? But now, how many pieces does Maya get? We need to think about when Dan and Muhammad they were planning to cut the rope, they have marked some points. It's the same rope. Okay, so we need to first find what is the GCD for 12 and 16 pieces. Okay, that will come out to be 4 pieces, right? So that means 4 pieces will be common, and 4 pieces obviously means how many cuts? Just reduced by 1, that is 3 cuts. That means 3 cuts are the same. Okay, so the cuts which are common between Dan and Muhammad, we need to subtract it from the total cuts. All right, so let's see. We had 11 cuts by Dan, 15 by Muhammad, and the common ones which we got from the GCD, that is 3. Okay, because 4 was the pieces. So remember, cuts will always be less, and if you are counting the cuts, the pieces will always be plus 1. So we are subtracting minus 3 from the equation and we get 23 cuts. But the question is not about how many cuts Maya will make. It's how many pieces Maya get. So pieces means always more than cut. So it's plus 1. So total 24 pieces she will get. Okay. So very clearly we see option A is correct. Okay. Let's move on to our next question, which is question number 29. A very interesting, you can see it's very interesting question here. Emma is playing with the 7 caterpillar puzzle pieces shown. So you can see 7 pictures down there. She wants to build a caterpillar that has one head, one tail, and 1, 2, or 3 puzzle pieces in between. Okay. How many different caterpillars can Emma build? Okay. So it's completely, a counting problem where we need to find all the possibilities in which a caterpillar can be formed. Important thing. Let's just mark the important thing first. One head we have, one tail we have. Obviously, a caterpillar can have only one tail and one head, but in between, it can have one or two or three puzzle pieces in between. So there is no rule that there should be two or one or three pieces. It says or. So we need to count those possibilities as well. Let's just have a look at the picture. Okay. And let me give some notation to all these pictures. So here you go. Can you see there are two different kinds of heads visible and two different kinds of tails visible? Okay, this is also head, this is also head, and tail. You can see these two are tails. And how did I get to know they are heads and tails? Because can you see the round curve here? So obviously, if I try to put this somewhere in between, I will not be able to attach from both the ends because there is only one puzzle piece which you can attach from one side, not from the other end. Okay, so clearly for the tail also we can see it's a round curve here at the end and there is only one puzzle fix on the left hand side. Similarly here also there was only one fix on one side. So that means we have two options for both head and tail. All right. So one thing is clear. The heads are going to be the first and the tails are going to be the last, right? So as you can see, I've already done some marking. So head one, let me take the first possibility and tail one, right? So I am picking head one and tail one. Okay. I'll talk about the other possibilities of heads and tails later. First, let's focus on the middle in between puzzle pieces. Okay. Head one, tail one. All right. In between, what is possible? They said there could be one puzzle piece, two, or three. So let's start with one. Can you think about, so these are the three pieces. Can you think about that one piece which will definitely be there no matter other pieces are there or not in between? So yes, you can see there's this piece which I've given a name as a star. I've denoted it by star. Why? Because it's so special. You can see how it is ending. So you can see it is ending with this shape, which will definitely be fixed to the tail. And on the left hand side, the shape will fix to either one or two and also to the heads, right? So this particular piece, which I have named as star, will be in between and can be fixed to both the heads and tails without the help of any other second or third piece, right? So one possibility we get is where I get a caterpillar starting from head one, star and tail one. Okay. So down below you can see I have shown this. This is how the caterpillar can be formed with three puzzle pieces. Second case where I have taken head one, tail one, obviously. So I've fixed head one, tail one. Now I'm taking up the second piece and the star. Now why I have kept the second piece first? Can you see? Because if I keep the second piece first, so what will happen? This end will easily fix in this end. That's why I've kept the second puzzle piece in the front, right? But if I would have done the opposite way, what would be the problem? Then we could have fixed the star. If let's say the star would have been in front, then this will never be fixed here. Not possible. Okay? So please do make sure that whatever you are choosing and selecting, it should actually make the logic, right? So what is the third possibility? Where I've taken one and the star. So you can see one and star. One is here and star is here. So easily they can lock it up here and this will obviously move to T1 and this will be moved to H1. Next possibility where I take both 1 and 2. So possible enough. 1. So after head it's 1. After 1 it's 2. So you can see this will fix here. After 2 it is star. So you can see this will fix here. And then star will fix in the tail, which is this. Right? And the last one, which is 2, 1 and star. So there is no problem if I shuffle between 2 and 1 or 1 and 2, right? Order can be changed. But obviously they are different puzzle pieces, so we have to consider this possibility as well. We cannot skip it, okay? Can you see how many possibilities are there when I am forming the caterpillars, keeping head 1 and tail 1 as the beginning and the end? So you can see there are possibilities 1, 2, 3, 4, and 5. So let me just highlight it. 1, 2, 3, 4, and 5. So 5 caterpillars can be formed, but still our question is not over. This is one possibility, right? So H1, T1, and in between this entire network of 5 possibilities, okay? Total count is 5. Similarly, the same network which I have drawn here can be between H1 and tail 2. All the 5 networks. Similarly, it can be done between H2, T1 and H2 and T2, all the 5 networks, right? So total how many possibilities are there? 5 plus 5 plus 5 plus 5. So total 20 possibilities are there in which we can create different caterpillars. Okay. So option is E. I hope you understood this question. Yes. So you can see option E is right. Moving to our last question for today, that is question 30. Ava writes a 3-digit number on the whiteboard. Then Brandon writes a 4th digit to the right of the previous ones. He says, look, the number increased by 2024. What digit did Brandon write? Okay, so let's say the 3-digit number which Ava writes be ABC. Okay, so ABC I am representing as digits. So A, B, C could be any 3 different digits. Okay. And let's say what Brandon did. What Brandon did? So Brandon writes a 4th digit to the right of the previous ones. So right side of ABC is what? Next to C. So this is the new number we got, ABCX. I've taken X to represent the 4th digit which is added by Brandon. On the right side, you can see it's on the right side. Okay. And they are saying when you get 2 different numbers here, the number is increased by 2024. So if it is increased by 2024, can I say that the difference between these 2 numbers is actually 2024? Isn't it? Because if it is increased by 2024, so if I subtract this, what I should get. All right. So we need to find what is this hidden X value. Okay. So the best way is, I would say, check every option and whichever fits well according to this particular calculation, that will be the correct answer. So I can show you one example and then you can try for all other options. So let's try with the first option, that is X is 2. Now you think if X is 2, don't forget to have a look here. Okay, so if X is 2, what could be C such that your answer is 4? Obviously, 2 is a smaller number, right? And anything smaller than 2 will never give you 4. So you have to carry over something, isn't it? So it should be 12, right? And 12 minus what gives you 4? 8. Okay. So this means 12 minus 8 will give you 4. So 8 is what? 8 is the value for your C, right? If C is 8, then it means what? If C is 8, What should you subtract from 8 so that you get 2? What do you think? Okay. Now, don't forget, if this was 8, x carried 1 here to make it 12. So that means this should actually be 7, not exactly 8. Okay, so don't be mistaken there. And we get 7 minus 5. That gives you 2. Okay, so that means the value for B becomes 5. If B is 5, then it means what? If B is 5, so what should be the value of A so that we get 0? So C didn't carry anything from 5. So let 5 be as it is. So that means A should be also 5, right? So we see that A should also be 5. But then what's the problem? The problem is if A is 5, here also it's 5 and this should be 5. Is it not contradicting? Because we already know the answer, it is 2. That means option A is definitely not the right answer. So let's just try for all other options. You can try at home and it will be a fun game for you. But let me tell you what will be the correct answer. So the correct answer is going to be the value 8. Why this digit is correct? So let me just explain you for 8. Okay, so if x is 8, so if x is 8, let me use a different color. If x is 8, so 8 minus which number gives you 4? Obviously 4, so C should be 4. Okay, this is sorted. 4 minus what should give you 2? Obviously, it should be 2. So B is 2. So wherever B is 2, I'm writing that. 2 minus what gives you 0? Obviously, it's 2. So A is 2. And here, we don't have anything below 2, so that is 2. So you can see all the answers are right, which with the digit 8. So we started with 8 and everything worked well. So that means x equal 8 is the correct answer. So with this, we are done with all the 5 new questions and I'll see you with more videos with more questions. Till then, keep learning and keep enjoying the subject. I'll see you. Bye-bye.